It powers athletes, fills lunchboxes, and generates billions annually. But before it becomes the creamy spread we know, the humble peanut must survive a brutal industrial gauntlet. Found in 94% of American pantries, this legume is an agricultural giant. To keep up with global demand, the processing must be fast, furious, and flawless. Today, we are tracing the 3,000-mile journey from the underground darkness to the golden jar, witnessing the fusion of farming muscle and engineering marvels. This is the story of how raw earth is transformed into premium, creamy perfection. Welcome inside the state-of-the-art facilities that make it all possible. The journey begins here, in the rich sandy soil of the American South. Unlike most nuts, peanuts don't grow on trees, they mature underground. After pollination, the flower sends a peg down into the earth. There, in the darkness, the peanut pod swells and matures over several months. When they are ready, massive digger shakers invert the plants. This is a race against time. Fresh peanuts have too much moisture and must be field-dried rapidly. They remain in the field for several days. If they stay damp, mold attacks. If they dry too fast in the sun, the flavor is ruined. It's a delicate balance. Once dried to the correct moisture level, the combine moves in. This machine separates the peanut pods from the dry vines. Inside the combine, violent threshing drums and shaker tables ensure only the pods are kept, while the remaining plant matter is returned to the field. The harvested pods are transferred into transport wagons on the fly. The coordination between drivers must be flawless to maintain efficiency. Truckload after truckload leaves the fields, heading to the first stage of industrial processing, the buying point and drying station. Here, the peanuts are subjected to controlled forced air drying to bring their moisture content down to a stable 10% for storage. Before they can enter the food chain, every load is sampled and graded by inspectors for moisture, size, and potential damage. Once approved, they are stored in massive warehouses, waiting for their turn at the shelling plant. The journey continues at the shelling plant. Here, the goal is purification, removing everything that isn't a perfect peanut kernel. First, the Destoner. Using vibration and air currents, this machine makes heavy rocks sink while the lighter peanuts float onward. A gauntlet of screens and shakers removes sticks, dirt, and any remaining field debris. Only clean pods move to the next stage. Next is the shelling itself. The pods pass between massive friction drums adjusted to the exact size needed to crack the shell, but spare the kernel inside. The result is a mixture of kernels, broken shells, and a few stubborn pods that need a second pass. Powerful air aspirators suction away the lightweight shells, leaving the heavier kernels to drop to the next stage.
The aspiration chamber utilizes strong upward air currents to lift the lightweight shells into the cyclone, while the heavier
Gravity tables use vibration and tilt to separate the nuts by density. Premium, dense kernels migrate one way. Lighter, lower quality nuts move another. The kernels are then sorted by size through a series of shaking screens, ensuring uniformity for the roasting process later. Finally, the ultimate quality check, optical laser sorting. This is where computer vision meets food safety. High-speed cameras inspect every single nut in milliseconds. If it's discolored or damaged, a precise burst of air shoots it out of the line. This technology ensures that only near-perfect kernels make it into the final product, removing defects the human eye couldn't possibly catch at this speed. The result is a pure stream of raw, graded kernels, ready for the next phase of their transformation. They are loaded into massive one-ton totes, sealed, and shipped to peanut butter manufacturing plants across the country. The raw ingredient is ready. Now, it's time to unlock the flavor. Hundreds of miles later, the raw peanuts arrive at the peanut butter factory. We have moved from the rough stage to the clean stage. The standards here are akin to a pharmaceutical lab. The first step here is the most crucial for flavor, roasting. The kernels enter continuous ovens heated to exactly 320 degrees Fahrenheit. This is where the Maillard reaction occurs. The heat transforms amino acids and sugars, turning the nut golden brown and releasing those distinct savory oils. They emerge transformed, but they are cooking from the inside out and must be stopped immediately. Rapid air cooling locks in the roast level. If this step fails, the peanuts will taste burnt and bitter. Next is blanching. Rubber rollers gently rub the roasted nuts. Because they are cooked, the red skins are brittle and fall right off. Air jets separate the light skins from the heavier nut, leaving only the pure, golden white roasted kernel splits.
The mixture of splitsture and skins passes under powerful vacuums. The light skins are sucked away instantly.
A second round of optical sorting ensures perfection. Any nut that didn't roast evenly is removed here. Finally, human eyes provide the last check before the physical transformation begins. These are perfect roasted peanuts. In seconds, they will be a liquid. They are held in massive surge hoppers, ready to be fed into the heart of the operation.
This massive surge hopper holds tons of roasted peanuts, ensuring a steady, constant feed rate into the grinder below.
Step 1. Texture engineering. The first grind crushes the nuts into a coarse, medium paste. This paste enters a mixing tank where ingredients are added: salt, sugar, and crucially, a stabilizer. Without stabilizer, the peanut oil would separate and float to the top of the jar. This ingredient creates the structure that keeps the butter smooth and spreadable. The mixture is then pumped into a high-speed mill. This reduces particle size to microns, creating that signature velvet texture. For crunchy varieties, chopped nuts are folded back in after the fine grind. The friction of grinding heats the butter to 170 degrees. It must be cooled rapidly in a heat exchanger to 120 degrees to crystallize the stabilizer correctly. Lab technicians constantly monitor viscosity. If it's too thick or too thin, the entire batch is flagged.
The resistance measurement is crucial for quality control. The viscosity is right where it needs to be.
The finished product is held in massive buffer tanks, a reservoir of golden spread ready for the final sprint.
Here in the holding tank, a slow-moving agitator keeps the finished peanut butter perfectly homogeneous, ready for the filler.
The packaging line is a blur of automation, starting with robots depalletizing thousands of empty jars. Every jar is inverted and air rinsed to ensure absolute cleanliness before receiving product. This is the heart of the packaging line, the high-speed filler capable of filling 500 jars every minute. Nozzles descend to the bottom of the jar and retract as they fill, preventing air pockets that could affect freshness. Lids are sorted, fed, and torqued onto the jars in a fraction of a second. An induction sealer uses magnetic fields to fuse the foil freshness seal to the jar rim without ever touching it.
Cap jars pass on cartless induction sealer. Machine instantly fuses the foil freshness.
After a quick cool down to set the seal, high-speed machines apply the labels. The final gatekeeper is an
The
X-ray
X-ray
scanner.
system scans
It looks
each
right through
jar
the
for
jar,
density
ensuring
variations.
absolutely no
If a
foreign
foreign
objects have
object is
entered the
detected,
product.
like
Robotic
The
arms
automated
gently
case packing
pack the
robot
jars into
uses a
cases,
vacuum gripper
ready
to
for
precisely
distribution.
lift a dozen jars at once.
Cases are sealed and stamped with tracking codes, ensuring full traceability back to the specific farm batch. Meanwhile, in the lab, scientists test for aflatoxin, a mold byproduct. Safety is paramount. A single failed test halts the entire operation. At the end of the line, palletizing robots build towering loads of finished product. The pallets are shrink-wrapped for stability, securing them for the final leg of their journey. They are staged in massive warehouses, awaiting orders from retailers across the globe. From raw earth to sealed jar, the process takes less than 24 hours once the peanuts reach the factory. Each jar contains roughly 540 individual peanuts, now flawlessly processed and heading to a store near you. From a flower burying itself in the dirt to a laser-sorted, precision-ground engineering marvel. That is the incredible industrial journey inside the jar. Which part of the process surprised you the most? The underground harvest or the laser sorters? Let us know in the comments.